For this video, we're looking at some slightly harder examples with logarithms when you're taking the derivative. So if I looked at this, it says f of x equals the natural log of this whole thing, x times x squared plus 1 squared over the square root of 2x cubed minus 1. If I just wanted to do this with u substitution right now, this entire thing would be my u. And to find u prime, I would have to do the product rule, because there's things multiplied, the quotient rule, because there are things divided, with u sub, because there's more than one term in here, more than one term here. So that would be a mess. So instead, one of the beautiful things about logarithms is that we can actually use properties of logarithms to simplify this equation greatly. So I'm going to start doing that. Now I can see multiplication right here. It's x times x squared plus 1 squared. I know that multiplication goes with addition, so I'm going to rewrite this function and say it starts with the natural log of x plus. Now, it's x squared plus 1 squared. I know that powers, when you're working with logarithms, can be brought to the front, so I'm going to say that this is plus 2, the natural log of x squared plus 1. So again, if you look at this, this 2 can come up here, and the addition is really goes with multiplication. And then right here, there's some division, that fraction bar right there. So I'm going to divide, but division and subtraction go together, so I'm going to subtract. And then this is the square root. I know that that's really a half power, and I know that powers can be brought to the front, so minus 1/2 the natural log of 2x cubed minus 1. And if you look, this negative in here is implying that something's in the denominator, negative exponents. Remember, logarithms we're looking at exponents here. The 1/2 is up here, it means it's the square root. The subtraction means we're dividing by it. Well, this is my new f of x. And you can imagine what it would look like if I did the problem the other way with my u prime. But this way, it's fairly easy. I'm going to say f prime of x equals, and I'm going to take the derivative term by term. So I know the derivative of the natural log of x is just 1 over x plus 2 times the derivative of x squared plus 1 is going to be the u prime over u. So times 2x over x squared plus 1 minus 1/2 times, and then again I have u substitution, but this is an easy u substitution, so u prime over u is 6x squared over 2x cubed minus 1. And I'm going to rewrite this one time to make it look better. F prime of x equals 1 over x times 4x, plus 1 over x plus 4x over x squared plus 1 minus, and then I can cancel this 2 out with this 6, and that makes it a 3x squared over 2x cubed minus 1. And that problem is finished. If I look at this next example, it looks about as miserable as this one. The problem here is that there's no natural log. This is the kind of problem that you say, I really wish there was a natural log in front of this so I could break it up. Because without it, I have to do the quotient rule because of the division. And then I have the chain rule twice because there's 2 sets of parentheses going on here, so this is a mess. So my very first step, instead of starting that process, is actually to take the natural log of both sides. So I have the natural log of y equals the natural log of all of that, which is the square root of x cubed minus 1 over x minus 4 cubed. And what that's going to allow me to do is actually split this up using properties of logarithms. So I'm going to say the natural log of y equals, and I'm going to look at the numerator first. It's under a square root, and I know that that means it's to the 1/2 power. Powers can be brought to the front. So 1/2 the natural log of x cubed minus 1. There's division. Division goes with subtraction. And there's a power. Powers can be brought in the front. So minus 3 times the natural log of x minus 4. And you can see that this looks a lot better in terms of taking a derivative. So what we're going to do here is take the derivative of both sides with respect to x. Now keep in mind, this y right here is not an x. So this is actually a u substitution problem. So u is my y, and u prime would be the derivative of y, which is y prime. So the natural log of u is u prime over u, so I'm going to say it's y prime divided by y, equals 1/2, and on this side I'm taking the derivative with respect to x, so I don't need to do a times dx or times an x prime, but it's u prime over u, so times 3x squared over x cubed minus 1 minus 3 times, this is again u substitution, 1 over x minus 4, u prime over u. So if I simplify this a little bit, I have y prime over y equals, and I'm going to say that this is a 3x squared. You can distribute the 2 in or just leave it outside like this, minus 3 over x minus 4. And unfortunately at this point you are not finished, because your goal was to find y prime, find the derivative, and I have this divide by y over here. So it's a simple fix. I'm going to take this y and I'm going to multiply it to the right. So y prime equals 3x squared over 2 times x cubed minus 1 minus 3 over x minus 4, and I'm going to multiply all of this by y. Now if they said you could leave the derivative in terms of x and y, you're done. If it says to leave the derivative in terms of x, you are not done, because I have a y sitting here on the right. But that too is an easy fix. It may look ugly, but it's not hard. This is 3x squared over 2 times x cubed minus 1 minus the 3 over x minus 4, and then I'm going to multiply it by y. What I'm really going to do is multiply it by what y is equal to, and y is equal to this expression up here. So if I want all of this in terms of x, I know that I'm multiplying by the square root of x cubed minus 1 over x minus 4 to the third. And this would be my y prime. It is an ugly derivative, but think about what you would have had to have done if you did it the other way. We're going to do one more of these, and you can see that it's incredibly ugly. And in fact, some things could cancel out right now that would make it better, but I want to show you something with this. So they should cancel out in the end when we actually have our derivative. But you have something that involves product rule twice, quotient rule, and chain rule multiple times. So instead, I'm choosing to use logarithms. So I'm going to say the natural log of y equals the natural log of all of this thing. So 2x cubed times the square root of 4x squared minus 7 over 5x squared times x plus 2 to the fourth. So using my properties, I'm going to simplify this greatly. You could split the 2 and the x cubed up because those are multiplied, but what you're looking for are things that are easy to take derivatives of, and 2x cubed is a really easy derivative. So I'm going to leave those together and say it's the natural log of 2x cubed. There's multiplication right here, so I'm going to say plus, this is the square root, so I'm going to bring the 1/2 power down. And then this is where students often go wrong. They will put a minus here because of the division, and that's correct. And that 5x squared is easy to take a derivative of, so I'm going to say it's minus the natural log of 5x squared. And then they put a plus right here. But I'm dividing by the x plus 2 to the fourth. So you either have to have a set of parentheses around all of this and then distribute the negative, or just understand that I'm also dividing by x plus 2 to the fourth. If I brought it up, it would have a negative exponent, so I'm going to put a minus, and then the power is the 4, natural log of x plus 2. And if you go the reverse direction, you'll see why that happens. But this is in the denominator, so I'm dividing by it. Everything in the numerator gets a plus because it's in the numerator. I'm multiplying. Everything in the denominator gets a minus. Now, things to note here, don't bring this 3 down, because the 2's in front. Now if I had split these up as the natural log of 2, then I could say plus 3 times the natural log of x, but this 3 is not on the 2, so you can't bring in front of this natural log, nor can you do that over here because this squared is only on the x, not the 5. Okay, I'm ready to take the derivative. So again, this is a y, not an x, so I'm going to say this is y prime over y equals, I'm going to take the derivative, so 6x squared over 2x cubed, and you can see a bunch cancels out, plus 1/2 the derivative of this is an 8x over 4x squared minus 7 minus the derivative of this is a 10x over 5x squared, and again things will cancel out, minus 4 times the derivative of x plus 2 is 1 over x plus 2. So my y prime will equal, and this will be a 3, 6 over 2 is 3, and I'm left with 1x in the denominator. My 2 cancels out with this 8, so plus 4x over 4x squared minus 7. The 10 and the 5 cancel out to a minus 2. The x's cancel out, leaving 1x in the denominator, minus 4 over x plus 2, and this would all be multiplied by my y prime over y. And if you look at this, I have some things subtracting here to cancel out, and it should happen because if you look at these x's cancel out. So 3 over x minus 2 over x, there is a common denominator, that's 1 over x. And I'm just writing everything else down. So y prime equals. The last thing I need to do is substitute my y, which is this very ugly function. You could substitute the simplified version, cancel out some x's, or just leave it like it is. I'm going to cancel out some x's right now because it's hard to pretend I don't see that. And that problem is finished. Enough. Again, it's not like we couldn't distribute in there, but until you know what you're going to use a problem for, there's no reason to do more to it.